Okay, so let me share my screen with you so we can talk about circumscribed angles. And if you've got your packet handy, these three examples will be the only ones we're covering today. Come on, there we go. Okay, so you should see your notes packet. So a circumscribed angle, we had the central angles whose vertex was at the center, and a circumscribed angle is formed by two rays that are tangent. So notice the vertex is outside the circle, but it is an angle that is basically touching the outside of the circle as well. Like they're not cutting through, so they're tangent. So notice that we have these points right here and here. And wherever a tangent line meets a radius, it forms a right angle. Okay, that's something that we'll probably talk about. So when we look at this quadrilateral that's formed, if this is 90 degrees and this is 90 degrees, and a quadrilateral adds up to all the angles inside add up to 360, then 90 plus 90 is 180. That means that these angles right here are supplementary. So the central angle and the angle that's outside, so the one that's basically the opposite it, they are going to be supplementary angles. Okay, so they also, the thing that it is formed is the circumscribed angle is going to be supplementary to that arc that it forms. Because if you think about it, a central angle right here, like angle D, is equal to that arc that's formed. And since this angle and this angle add up to 180, then this arc and this angle will be add up to 180. So okay, so not only are the central angle and that circumscribed angle supplementary, the arc itself that circumscribed angle forms is also supplementary. So let's go ahead and just look at a couple of these examples. In this case, we have this central angle right here, MNL, which is 120 degrees. And so we know that MOL is the one that we're looking for right here. Okay. And that those two are going to be, notice how this is a circumscribed angle. It is formed by two tangents. It doesn't cut through the circle. It basically has its endpoints of the angle are on the circle. And so we know that MOL plus angle MNL equals 180 degrees. So if this is 120, subtracting that from 180 degrees, we can see that in the measure of MOL would be 60 degrees. So 180 degrees minus 120. When we're looking at, in this case, they told us angle JKH, that's my circumscribed angle, is 30 degrees, and they are asking you to find JIH. And so again, we know that this is my circumscribed angle. It's forming a quadrilateral, and notice that the vertices of, two of the vertices of the quadrilateral are on the circle. And then we have a central angle and that circumscribed angle. So we know that the central angle plus this angle that's given to us, our circumscribed angle, so JIH plus the measure of JKH is going to equal 180 degrees. And so then we would know that, okay, well, this is going to be, when we subtract JKH, which is 30, so it's 180 degrees minus my 30 degrees, we now know that the measure of JIH is 150 degrees. Okay. And last but not least, we are looking at the measure of angle B is 52 degrees. All right, so there's 52 degrees. And they're actually asking us for the measure of angle AEC. Okay, so we're going to have to use a little bit of algebra skills and our geometry background knowledge to find some of this one. This one's a little bit different. I know I can find, remember that we know that this angle is 52 degrees. We know that the central angle and my circumscribed angle have to be supplementary. So we also know that this arc right here is going to be supplementary with this angle as well. So the measure of angle ABC plus, and I'm going to put the arc measure because we're actually finding an arc. So we know that arc AC is a central arc, and it's going to be supplementary to the circumscribed angle. So arc AC also has to be 180 degrees. And so now let me go ahead and substitute some of that in. We know then that the arc AC would be 180 degrees minus 52 degrees. And so that's going to be, let's see, 128 degrees. So I could find the same thing. I could say, okay, this angle is 128 degrees and this arc right here is 128 degrees. Okay, both of them. The central arcs are equal to the central angle that forms them. All right, so now that's not what we were asked. We were asked for this highlighted one, this major arc, and we know that a full circle, so arc AC plus arc AEC in a full circle have to add up to 360 degrees. And so I can subtract off my 128 from 360. I'm running out of room here. And that will help me find what my angle, or I'm sorry, my arc AEC is. So let's see, if I do 360 minus the 128, I get 232 degrees. Okay. A lot of the problems that we have are like puzzle pieces, right? It's not going to be necessarily a one-step or even a two-step problem. Sometimes you might have to use the one piece of information to find something else, to find another thing, and then finally find what you are looking for. Okay, so look at it like it's a jigsaw puzzle, and you just need to try and fit the pieces together based off of what they're given, and there's always something that will help you find something else, and it's kind of like a domino effect. Okay. Does anyone have any questions about these examples? So if there aren't any questions, see, I told you today would be a quick day. What I do want you to try and do is the quizzes that has been assigned to you already in Google Classroom. I would really prefer that we actually finish that before we log off, or at least I will watch and let you know if you've made enough progress, because we have so much time right now. I'd like for you to use this time while I'm here so that we for sure feel comfortable with central and circumscribed angles before we're moving on to something new, where tomorrow I won't be here to answer questions. Okay. So at this point, you can go to Google Classroom. Stop this.